Okay, so I thought it would be helpful if I went through how I would do this exit ticket for today. So you'll notice it's a matching section, and sometimes the matching doesn't work real well on formative. So I'm actually going to rewrite the Cn minus plus NH4 plus 1 yields HCN and NH3. So the first thing I always do with these kinds of problems is I look and see where the H's go. So I have Cn minus 1 going to HCN, so we are gaining an H. So the thing that gains an H is going to be your conjugate acid. Okay, so the opposite of your conjugate acid is going to be your base. So the base is going to be connected to the conjugate acid, and acids will be connected to the conjugate base. So that means the other thing is your conjugate base, and the NH4 plus would be an acid, and so that would be how you would do that kind of a problem. So trace where the H's go and then figure it out from there. Recall that acids and bases have to be on the reactant side, and conjugates are always going to be on the product side. So here's another example of that. So we have HCO3 minus plus OH minus going to CO3 minus and H2O. So what jumps out at me is the OH minus is becoming a HO. So that's where that H is going. We're going to gain an H. So if we're getting an H there, that means this guy is my conjugate acid. So the opposite would be my base. So the other thing must be my conjugate base, and then that would be my acid. So then we go on to the next problems, and it says find the H3O plus concentration in an acetic acid solution that has a pH of 5.12. This is technically a weak acid problem. I don't think I meant for that on there. So if this was a strong acid and we have a pH of 5.12, our H plus concentration would be 10 to the negative pH. So it'd be 10 to the negative 5.12. You take the antilog, and that is 7.59 times 10 to the negative 6 molar. I think this was intended to be a strong acid solution. So we're going to ignore this at acetic acid because you wouldn't have known how to do a weak acid problem quite yet. And then the next one, in a solution, you have H3O plus is found to be 3.5 times 10 to the negative 5 molar at 25 degrees C. Find OH minus. So we know there's this equation. H plus times OH minus equals 1 times 10 to the negative 14. So we're going to plug this number in to here. And so it's going to be 1e negative 14 divided by 3.5e negative 5. And I found the hydroxide concentration to be 2.86 times 10 to the negative 10 molar. So then calculate the pH of a 0.55 molar solution of sulfuric acid. Again, whenever you see an acid written out, I would go ahead and translate it and notice it is a diprotic acid. So the pH is going to be equal to a negative log of 0.55 times 2. Okay, so negative log of 0.55 times 2 is a negative 0.04. Most people got this wrong. Did the math right, they just didn't realize it's a diprotic acid. Okay, next one, you have a concentration of 3 times 10 to the negative 4. That is of OH minus. So what I would do personally is I'd probably find my POH first. It's the negative log of the 3 times 10 to the negative 4. So the negative log of 3 times 10 to the negative 4 is 3.52, and then my pH would be 14 minus that number. So that would be 10.47 or 10.5. So hopefully that helps you.